Okay, so there are a couple of inaccuracies in the Module 4 presentation. So I wanted to go a little bit over those calculations and just make a couple of observations, right? So first of all, you were asked to find, right? You were asked to find marginal revenue and marginal cost, right? And so at first you wanted to find marginal revenue, right? R prime of x, right? Okay, so revenue of x was what? X squared plus 20x. So if I want to find the marginal revenue, I told you marginal just means taking the derivative. It just means taking the derivative of this this expression. How do I take the derivative of this expression? Well, it's a sum, so I can break it up into two pieces, right? Take the derivative of each term in here. Then the derivative of the first term, well, that's a power, right? I can use the power rule. Drop the exponent down, yeah? So I'm going to get 2 times x and then subtract 1 from the coefficient plus, now I have a constant in front of x, right? So that comes out in front of the derivative sign. So I'll get 20 times the derivative of x. Yeah, so what do I have? I got 2 times x to the 2 minus 1 to the first power, right? 2 times x plus 20 times the derivative of x is just 1. Yeah? So the marginal revenue is 2x plus 20. Right? So now if you're asked for the revenue from selling the 51st item, well, that's the same thing as finding the marginal revenue of 50, right? Because marginal revenue means the revenue from selling one extra, right? The 51st in this case. So all I have to do is plug in 50 for x, and I get the 120, right? The 120, right? I think there's a little bit of confusion there in the text. The result is 120, but the text says 20. Okay? I can do the same thing for the cost, right? The cost is, 40x plus 100. The derivative of the cost is going to be, right, the derivative of 40x plus the derivative of 100. Well, the derivative of 40x is just 40, and the derivative of 100 is 0. So the marginal cost is 40, right? The marginal cost is 40. Means whatever I plug into x is still 40. Yeah? That makes sense, right? That, remember that the cost is a line. It's got a constant slope. So no matter how many items I buy, yeah, right, it translates into no matter how many items I buy, each extra one costs $40. Yeah. Now, you're also asked about the optimal number of items to sell to optimize profit. Okay, so if I look at profit is revenue minus cost. Yes, profit is revenue minus cost. And I know in your text it says that just find the point where this equals this. Yeah, or the derivative of the revenue equals the derivative of the cost, and that's correct, right? But it's all coming from this, right? It's all coming from this. So I'll show it slightly. I'll show it a little bit different, and I'll show you where the error is in the explanation there. So the profit, right, is gonna become what, revenue, right, which is what, x squared plus 20x, right, that's revenue. I'll put a parenthesis around it, and then minus cost, which is 40x plus 1000. Yeah, so the profit is gonna become x squared plus 20x minus 40x, right, minus 20x, and this negative is gonna distribute, so it's gonna be minus 1000, right? So the profit x squared minus 20x minus 1000. If I take the derivative of this, right, I take the derivative of this, what do I get? I get d dx of x squared minus 20x minus 1000, and this is 2x minus 20. That's the derivative. Yes, that's the derivative. Now let's look a little bit at the graph of the profit, right? So I'm looking at this equation here, right? Well, that equation, again, it's a quadratic. Yes, it's a quadratic. So if I look at its graph, it actually looks like this. Yeah, it's a parabola, it's a quadratic with the tip pointing down. This vertex, right, this lowest point right here, that is where the derivative equals 0. Yes, that is this point. Yes, this point is found by setting the derivative that we found equal to 0, right? So if I find that, let's see, p prime of x equal to 0 means 2x minus 20 equals to 0, which means x equal 10. So it means that this point here that corresponds to the vertex, this is x equal 10. The only problem is this is not the highest point of the profit. It's, in this case, it's the lowest point in the profit. So, just to, what was I trying to say? There's the mistake that I was trying to emphasize is that this x equal 10 is actually giving you the minimum profit. And it has to do with these quadratics, right? Some quadratics point down, and some quadratics point up, right? Point up, yeah. For both of them, the coordinate of the vertex is found by, let's say we're talking about profit. This is where p prime of x equals 0. This is where the p prime of x equals 0. So yes, by setting the profit derivative equals to 0, I do get the coordinate of the maximum or the minimum. Yeah. What I have to pay attention to is the coefficient of x squared, right? The coefficient of x squared. So I found that the equation of the profit was x squared minus 20x minus 1000. Because the coefficient of x squared, which is, it's understood to be 1, right? Because this coefficient is greater than 0, that's why we get a quadratic that's pointing down, right? So I get and actually I'm getting a minimum profit, not a maximum profit, right? So you just have to be careful about that.